Look at Earth. It is the vibrant, blue home we know so well, teeming with life and floating steadily in space. And right next door is its constant companion, the Moon, which illuminates our nights. It feels permanent. But did the Earth always have this massive celestial neighbor? 4.5 billion years ago, the picture was very different. The early Earth was isolated, spinning alone in a dark, empty void. Since the night sky was entirely empty back then, the Moon we see today had to be created during a specific, violent event in our planet's history. In the early solar system, space was crowded with rogue celestial bodies. One of these bodies was a planet-sized object roughly the size of Mars. This massive body was traveling on a direct collision course with the young Earth. Traveling at thousands of miles per hour, the two worlds collided. The impact was powerful enough to pulverize the outer layers of both planets. This spray of molten rock and vapor was thrown out into the vacuum of space. While this event shattered the early Earth, the spray of debris it generated would eventually provide the raw materials for a new world. Instead of floating away, Earth's gravity acted like a net, capturing the ejected rock and dust. This material settled into a swirling ring of debris that orbited the damaged Earth. Over time, these small fragments constantly bumped into one another and stuck together in a process called accretion. As these clumps grew, their increasing gravity pulled in more of the surrounding dust and rock. Eventually, these massive fragments fused together, cooling into one solid spherical mass. The Moon we see today is essentially a graveyard of rocky fragments from both the early Earth and the planet that struck it. 4.5 billion years later, the Moon remains in orbit, its surface cooled and hardened. The rugged craters and jagged mountains we see are the physical evidence of its violent, chaotic origin. Scientists have a specific name for this sequence of events. This is the giant impact theory. It describes the massive scale of the object, the force of the collision, and the scientific process that turned the debris into a satellite. It remains the most widely accepted scientific explanation for the Moon's existence. Our companion is the result of a collision between the Earth and a Mars-sized object billions of years ago. The next time you see the Moon in the night sky, you are looking at the remnants of Earth's most violent day.